All right. I am going to.
Guys, I literally probably like.
That's way too dark, right? Are you sure?
I like that.
Jill, you're the start of my April recast.
You know what I need is I need to put a light back there.
Yeah, like a light in the back.
Why don't you get Christmas lights?
I should do those LED strips that you all do in your bedroom.
Sure.
I
Yeah.
should.
Just turn on like the normal like white color. You don't even have to make it look like this.
Yeah.
Yeah, this sticky note.
A sticky note?
Yeah, could you put a sticky note on like the front part of like where that light is? I have like there's like when you look up.
Does it shoot at you?
It like
Gotcha.
I have really bad vision in general. So then that contrast.
Like that?
Yeah, that's so much light. Thank you.
You're welcome. Okay, so we did the odds on the back, right? So let's take a look. I just thought, I know we missed April Fools this year, but I just thought of a funny one. You gotta pick someone and then don't tell them, but the rest of the class, like you have everything super out of focus. Like I leave it like all blurry, but everybody else acts like it's in focus, and then one person is like, what is wrong? Why can't I see anything? Really funny.
Do that to Jack, he's not here right now.
Oh, okay. But I don't know how to make it blurry now.
But like, I don't know.
But bring in a
wave,
piece of
put your-
saran wrap or something and put it
Yeah.
over.
Well,
Put your hand on it, like, put your hand on the camera.
You can blur it. Yeah, I think you can.
how do I, and then I gotta focus up here.
Yeah, you should be like, can everybody see? Yeah, that's so
Yeah.
But he's
good.
not gonna look up anyway.
Oh.
Yeah. But, all right, anyway, so what are we doing here? We gotta find all the zeros. They didn't give us any to start with. So we have to come up with that really cool list. So remember where the list comes from. You need to take factors of your last number. So in this case, that's 9. So let's list off the factors of 9. 1, 3, and 9. Bless you. Then you need the factors of your lead coefficient, which in this case is 4. So 1, 2, and 4 are the factors of 4. So to come up with that really cool list of possible rational roots, it's going to be positive and negative, all of these numbers. I'm going to take all of these and divide them by 1. So that's 1, 3, and 9. That's easy. But now I have to take all of these numbers and divide them by 2. So I get a half, 3 halves, and 9 halves. And then I have to take all of those numbers and divide them by 4. So I get 1/4, 3/4, and 9/4. So look at your papers. That should be your list. Positive and negative, all of those. Yes? You got that part? Okay. Now comes the tedious part, because now I'm just literally going to plug these numbers in one at a time, doing synthetic until, what am I looking for? What am I trying to get? Yeah, I want to get 0 as my remainder. So let's drop down our coefficients. 4, -3, 12, -9, 3, 2, 1, none. I don't need any 0 placeholders. So I'm literally just going to go down the line. I think I gave you a hint yesterday that this one is going to be a fraction. So you just keep, I know it's annoying when I give you the test. I try and make sure that the list is not so long. So maybe there'll only be like 6 numbers in the list, or 3, positive and negative. You know what I mean? So I'm trying to make it smaller so there's not quite so many, because it's just annoying. But I think the one that ends up working is a positive 3/4. Yeah, okay. So drop down my first number, 4, multiply. By the way, I noticed yesterday that some people have forgotten how to multiply a fraction and a whole number. You're doing way more work than you need to. If you're doing 3/4 times 4, just divide these two. Divide down, multiply up. 1 times 3, you just get 3. That's just a 0. And now, ooh, look how nice, 12. So now when I want to do 3/4 times 12, your easy way is divide first. 12 divided by 4 is 3. 3 times 3 is 9. Oh my gosh. It worked. And now this is where you're at. Whatever is left, these are the coefficients of your, I don't know, I guess I think it's called the depressed polynomial because it's not my biggest one. I made it smaller now. So anyway, I have my remainder on the end. There's my constant x to the first x squared. So when I write this nice and neat, it's just 4x squared plus 12. And all you have to do now is solve this quadratic. This is easier than you think. You don't have to do quad formula or complete the square on this one. Can't you just minus the 12, divide by 4 and take the square root? You sure can. I mean, you could have done quad formula. I have someone in D block who has said, I'm always going to do quad formula no matter what, even if it's easier to do it another way. And that's their choice. They're just spending a lot more time than they need to. Because now look, I'm already here. And then all I have to do is take the square root of both sides. Boom. When I take a square root, what do I need to remember? Plus and minus. And you have a negative under there. So that's going to come out as an I root 3. That's 2 more answers. So I found 1 right here. And then there's my answers 2 and 3. Also, people were asking me yesterday, how are you supposed to know how many answers you're going to have? That goes all the way back to the beginning. It's just the degree of the whole thing. Whatever the degree is, that's how many answers you're going to get in total. Does that make sense? So that's a nice, easy way to check. So if that were multiple choice, oh my gosh, if you got so lucky as to have one, if I'm supposed to have 4 answers, but there's choices that have 5 answers, they're not right. That's a very easy thing to look for. All right, so is 15 okay-ish? All right. Should I just, do you want me to do all of them?
Yeah.
Yeah, okay. All right. All right, so 17, and I'm gonna go on another piece of paper. I need more room.
Wait, how did you know that?
I don't think we need to work that, do we?
Yeah,
Unless people say specific ones, I think we're actually.
well, there's conflicting evidence coming from the crowd. It's okay.
Oh, I
It
just
was
had a
all-
question.
It's okay. There's
Hey, I made the first.
Wait,
and
Miss
then
Lydia, I
you-
just had a question.
yeah.
Why did you like keep going? Like to like the 4x squared plus 12 is equal to 0? Like, why did you do that?
Because I need to find all the solutions to this.
Oh,
I know there's 3 of them, so I found 1 of them, but I need to use this to find the last 2.
oh, okay.
So now in 17, I'm gonna do the same thing. I'm gonna start off by making my super cool list. So I'm gonna sort of shortcut getting to my list, right? So I should have all of the factors of 15 divided by the factors of 2. So that's going to be all the factors of 15 divided by 1, 1, 3, 5, and 15. And then all of those same factors divided by 2. So a half, 3 halves, 5 halves, and 15 halves. This one was also a fraction. Was it? The one that worked? Or was this a nice one?
That one was a no, that one.
It was a nice one?
No, it
Oh,
was a fraction.
what was it?
It was -5 halves.
Negative 5 halves ends up being the one that works, apparently. So let's drop down our coefficients. 2, 5, -6, -15. -5 halves. So again, you would have, if I didn't give you a hint or you didn't know, you literally just start at 1. Try 1, try -1, try 3, try -3, try 5, try -5. Yes, it's tedious, I know. I'm with you. But sometimes that's the way the cookie crumbles, right? All right, multiply, you get -5. Ooh, how nice, a 0. That makes multiplying really easy. So now when I'm doing this, first of all, it's a negative times a negative, so it'll be positive. You do 6 divided by 2 is 3 times the numerator is a 15. Yes. I now have one of my three answers. It's -5/2. Yes. Now I'm going to use this to find the remaining two. Remember what this is. This is x to the first, x squared. So I have 2x squared minus 6 equals 0. And now I can solve this one just like I did 15. Add that 6 over. Divide by 2. Take the square root. Plus minus √3. Yes. An irrational solution. And what do you know? It brought its conjugate pair to the party because they always come together. So any Hoosers, there's my three answers, -5/2 and positive -√3. Does that make sense? Are we feeling better? Let's try 19. All right, this one's got a lot of, this one's gonna have a lot in our possible rational roots, isn't it? Yeah, sorry. All right, positive, negative. All the factors are 24. 1, 2, 3, 4, 6, 8, 12, 24. Oh boy. And now, oh, where am I? Not even on the screen. There we go. And then I also need all of these numbers divided by 2, but some of them are already going to be in this list. So if I do 1 divided by 2, that's a half. 2 divided by 2 is 1, which is already there. 3 divided by 2. 4 divided by 2, I have. 6 divided by 2, I have. 8 divided by 2, I have. I have. Okay, great. So that's not as bad. So there's my whole list, and I'm just going to do synthetic down the line until somebody works. Can someone tell me a number that works?
-3.
-3. Okay. Ah! Oh boy. What's that? -8. Positive 24 and a 0. Yes. So I'm trying to get that 0 remainder. I got it. Now look what I am left with, everybody. I'm left with 2x squared plus 7x minus 8 equals 0. This is just a quadratic. I can solve this. I'm going to try and factor it. I don't know if it's factorable or not. So I do slide and divide. So I want to see, are there factors in -16 that have to be a positive 7? No. Right? -16 getting to 7? Right? It's a no, right?
Yeah.
Correct. Okay. So now what am I going to do? I'm not going to complete the square on this. I have to do PUD formula here. Too bad, so sad. -b plus or minus big old square root. B squared is 49 minus 4 times a is 2 times c is a -8. All over 2 times a. There it is. Now, let's just evaluate. Let's see, that'll be a 49. So that's 8 times 8 is 64, and that'll be a positive, so 49 plus 64. Did you guys get a 113 under there?
Yes. I think so. Wait, no. I did not get that.
Let me make sure I didn't mess up.
No, I messed up. Because I forgot to, that was my fault. I messed up. Probably right.
I am in this case. So I can't simplify any further than that. That's 2 answers right there because you have -7 plus that, -7 minus that. So put that in conjunction with my -3 that I had from the synthetic, and there's my 3 answers that I was supposed to find. Got them. Yes. Are we a little bit better now? And last one. And this one, oh, you know what? We are, oh my gosh, we are silly geese. We are the silliest geese.
Why?
Because, oh my gosh,
What did we do?
all of these have had 4 terms. We should have been trying to like factor by grouping from the beginning. Oh my god.
Wait, so it didn't have to be that, like, we didn't have to write the list?
Well, you have to check and see if you can factor by grouping, because sometimes you can't.
Wait, I was doing that, so I wasn't wrong.
No, you're right. So like, let's look at number 19, for example. Number 19 would not factor by grouping. I could try. From this side, I could take out an x squared, but then you'd have 2x plus 13. This side doesn't match that, and you can't get it to match. So 19, you could not do by factor by grouping. But I'm looking.
Stuff you can do if you can't do factor by group.
Right. But we should always be, if I only have 4 terms, I should always be starting by trying to factor. Because it could, so I'm wondering, could we have done it on 15? You take it at 3. Gosh darn it, we could have done it on 15.
Well, look at
And
that.
17? Oh my gosh. Well, whatever. Lesson learned. 21, I think we can do it on. Yeah, we totally can. So 21, let's get smart finally. Factor by grouping. Take out an x squared. 2x plus 7. I bet people on the internet are like, oh wait, no, it doesn't work. Oh,
Well, good.
I thought we
because
had it.
Ange was confused on how you find the number. Like how I found the like -2 for the C, right? So, yeah, this makes sense.
all right. So we can't factor by grouping, although I thought we could, but can't. So what are we gonna do? We need our magic list, possible rational roots. So we're gonna have positive and negative. All the factors of 2 divided by 1, so that's 1 and 2. And then all the factors of 2 divided by 2, so that would be a half. And then 2 divided by 2 is just 1, and that's already in my list. So that's a nice small list. This would be an excellent test question because there's not that many. Okay, so now let's do synthetic. Actually, this is a great test question because you know something else about this number that I'm going to plug in. The number that I plug in has to be what? Negative,
Oh, yeah.
because all of these coefficients are positive. So if I plug in positives, it's never going to cancel out at the end. So I know it's going to be a negative. So there's really only 3 options. It's either a -1, a -2, or a -1/2. So I'll try -1. Let's see if it works. So -2, 5, -5, 2, -2. Oh, how about that? -1 works. Yes. So now I have these. Remember, that's x to the first x squared. So now I'm looking at 2x squared plus 5x plus 2. That's a quadratic. I should be able to solve it. This one does factor. I can do slide and divide here. If you don't like factoring, I don't know why you don't, but you could do quad formula or complete the square, whatever you want. Factors of 4 that add to be 5 or just form 1. I did the slide, now I gotta do the divide. Zoom in a little bit, sorry. So now my factors are just x plus 2 and x plus 1/2, which means that my zeros are actually going to be a -2 from that one, a -1/2 from that one, and we have the -1 that we found doing the synthetic. So there, they all are. Oh, how funny. So it wouldn't have mattered which -1 you chose. They all would have worked. Isn't that something? That would be an excellent test question. I almost wish I hadn't already copied your test. Because I don't know. I'm sure that one's not on it. Or maybe it is. I don't know. Maybe past me, surprise myself. Okay, do we feel better about the homework now? Does silence mean yes or no? Yeah? Okay, good. So today we're going to change things up a little bit. We're going to try graphing these things finally, because remember, what are these numbers really? You find these, but what are they? Yeah, that's where if I were to graph the original polynomial, these 3 spots are the locations where that thing is crossing the x-axis. So if I were going to graph, I'd have actually a pretty good starting place now knowing those 3 numbers. And if I combine that with the information that I'm about to share with you about the end behavior of graphs, you're going to be able to graph these like nothing. Are you ready to talk about end behavior of graphs? I knew you would be. All right, so I'm going to switch over to my notebook. So if you want to grab something somewhere to write some notes down on, that would be swell. I don't have a ton to write, so we'll just do a couple and then we'll practice.
Why is it red? It's weird. She from a tree. She from a tree. I know, part of me is like, yeah, and the other part's like, no. No, yeah. It's a little. Right, well, it's like, but like I actually learned it. Like I was like I didn't get the a weird, but like I just get.
Okay. So I want to show you some graphs before we begin on the graphing calculator here. So let me get this lined up so you can actually see it. There we go. So this is just the graph of x squared, right? It's just this parabola looking thingy. Do you know what an x to the fourth graph looks like? Let me show you. I'm going to change this to an x to the fourth now. Let's see. So it can look like a W, or it can, doesn't it kind of look like a parabola here? So what I really want you to do, kind of ignore the middle. I want you to look at the ends. Look at what the ends of this graph are doing. Remember what they were doing for x squared. Weren't x, well, let me go back. X squared, weren't the ends just going up to the sky? And now x to the fourth are going up to the sky too. That's interesting. I wonder what happens if I change it to an x to the sixth. Oh, my goodness. I guessed before you could see it. Yes, they're going up to the sky again. That's weird. Or is it? What if I tried x to the 20th? Is that weird? Or isn't it? I don't know. Let me try, if you notice, what are all those numbers that we just did? They're all even numbers. What happens if we throw an odd in there? Let's change it to an odd number, like a 3. Let's look, I know you remember from our parent function thingy, what the x cubed graph looks like. Oh, that's weird. They're not both going up to the sky anymore. I wonder what an x to the fifth graph looks like. I'll change that to a 5. Well, I'll be, what about like a 11? Weird, or not at all. Totally makes sense. So I hope you're catching my drift here, that if you have a polynomial whose degree is even, the ends are going to reach for the sky. Who says that? Woody?
That's like there.
Buzz says that?
Yeah, because he
No.
flies, like he flies.
Yeah, but Woody, you pull it and he says, reach for the
No, yeah,
sky.
Woody's
yeah,
like,
but he.
There's a snake in my boot.
No, yeah, but he also says reach for the, yeah. it says like-
Oh, because he's like.
No, that's Buzz.
Yeah,
No,
yeah,
but it says to infinity and beyond.
yeah.
Clever just.
Okay. Anyway, so that's what the even degree polynomials are doing. They're both reaching for the sky. All of them. Isn't that interesting? So no matter, guys, is everybody listening? So if my polynomial is degree anything even, it doesn't matter what comes after it. So if I change it, let's do, let's say I have x to the 4th. Oh my gosh. There we go. X to the, oh my gosh, what are we doing? These calculators are, so it's so funny because when like I was in school, I used the same calculator, but like not like now it's TI 84 plus. And so things work different. So I'm not used to all these, but anyway, whatever. It wouldn't matter what comes next. 5x to the 3rd plus 2x minus 4. Who cares? Those things don't matter because the degree of this whole thing is still even, right? The degree of the whole thing is 4. So this, even though I have no idea what this graph is going to look like, I kind of do because I know the ends are going to both be going up together. Let's see. Oh, of course. Hold on, I gotta fix it. What did I do wrong? What doesn't it like about this? Okay, there. So a whole bunch of things going on in the middle, but look at my ends. Both ends are going up. How cool. All right, so let's put this in some words on paper. And then we'll see how to put this all together. So what section is this? 4, oh no, not that. 4-6. So we're really focusing on end behavior today. Oh my gosh. Okay, so let me draw you. They could look all sorts of different ways in the middle, but on the ends, they're both going to be going up like that. So see how both ends, on this side it's going up, on this side it's going up. And that's going to be true for every even degree polynomial. So conversely, we have, if the degree is odd, so if your degree is odd, they're going to alternate, meaning one will be going up and the other is going down. And it is always in this pattern. This one always goes down to whatever on this side. You're going to have a whole bunch of stuff happening in the middle. I don't really care about that. And then this one's always going to go up. So you got one side over here going down to negative infinity. This one's going to shoot up off to positive infinity. And then unfortunately, I do have one more thing that complicates this a little bit. Because if you think of a parabola, let's just focus on a parabola, so an x squared thing. Are the ends always pointing up? No, can I have a parabola that's down like a frown? But the ends are still going the same way together. So how do I make the parabola go upside down? Yeah, my lead coefficient has to be negative. So if for either of these cases, if my leading coefficient is negative, the whole thing is flipped over. So I could have an even one where they both go down together. Or if my lead coefficient here is negative, then it would flop and I'd have this one going up and that one going down. I'm going to try and sneak that in right here. I'm sorry if this messes you up. Oh, I didn't think about that part. So this is if A is positive and if A is negative, it's going to look like this. So they would just go upside down. So same thing on this one. This is if A is positive. It looks like a T. I'm gonna fix that. And then if A is negative, we would do the same thing, just upside down. Okay. How are we feeling? You ready? I'm gonna need you to be ready to do stuff with your hands. You're gonna have to raise your hands in a second. Are you ready?
Yeah.
So I'm going to give you a polynomial. And I want you to show me with your hands what the ends would do. Okay. Show me with your arms what the ends of this thing would be doing. Yay, you reach for the sky.
Oh, your arms?
Yeah.
Oh.
What would the ends of this one be doing? Yes. So here, oh wait, they should both be going down together, right? Because my degree is even. So whenever it's even, it's like, okay, they're both going to be doing the same thing together. And then I just look, oh, A is negative, so they're both going down together. All right, let's try this one. What are these ends doing if it's x to the third? Oh, good. You should have this one going down and this one's going up.
Oh, wait, that is a curve.
It doesn't matter about the middle. No, we don't care about the middle. We just care about the ends right now. And let's do perhaps one or two more. Let me find a good one. What about, that's a great one. Oh, wait. There it is, that one. Oh, yay, correct. So this one, you gotta go opposite. This is what it normally is, but since A was negative, it goes this way. Yeah? Okay, good. So there's end behavior. So how powerful is that knowledge when you go to take your final exam that's multiple choice? If there was an MCAS question that was multiple choice like this, you could just look at the ends and immediately be able to rule some out. I bet you. Okay. We can talk about a few other things too. This is really cool. Let me zoom out a little bit. The number of times the graph can turn. Oh. Is one less than its degree. Oh, you know what? I should say the maximum number. Sorry. The maximum number of times the graph can turn is one less than its degree. All right, let me explain what I'm talking about. So if I had an x to the third graph, let's say, degree 3 graphs, there is no way, so don't draw this one because I'm going to erase it in a second. I know degree 3, so it's going to start, this side's going to go down forever, and then I'm going to have some things happening in the middle, and then this side's going to shoot off over here, right? Now, what's happening in the middle, what this is telling me is that if I go one less than that, that means this thing can turn at most 2 times. So I could have a graph that looks something like this. There's 1 turn, there's 2 turns. That's possible. So actually you could draw that one. What would not be possible is something like this. So if I had the ends, it can't go like this. That's impossible for an x to the third graph, because the most number of times it can turn is going to be 1 less than its degree. So this would be the max I could see. This, impossible. Too many turns. For x to the third. This, if I were like, if this were a multiple choice thing and I was trying to figure out who, maybe they give me the graph and they're asking what the equation is, it turns once, twice, 3, 4, 5, 6. This thing would have to be at least an x to the 7th graph or more. Isn't that interesting? Same thing for a parabola. We all know parabolas only turn the 1 time, which makes sense. Their degree is 2, so the most number of times they can turn is just once. So if I have an x to the 4th graph, put this out of my way. So another example, degree 4. The most number of times it can turn is 3. Max turns 3. And that's how you kind of get that W shape. 1, 2, 3 turns. They can look like a W. They don't have to look like a W, but they can. They can't, you know, have like a million waves in the middle. That would be the most. Okay, and then there's one last thing that I have to talk to you about, and then we're done. And then we'll just practice them. You ready? This one's kind of fun. I have to flip the page. Do I even have another page to write on? I don't know. Oh my gosh, I might not. Oh, I can just steal that space. I'll steal the space. All right, ready? Check this out. I'll ignore that factorial stuff. Oh yeah. So remember how we've been talking about double roots and like getting the same answer multiple times? Maybe you get it 3 times. We say with a multiplicity of 3 or whatever. Remember we've been talking about this? Yes. Okay, great. So it turns out, depending how many times an answer shows up, it can tell you what the graph, what's happening on that point. Okay, so check this out. If a polynomial has answers that appear either once or an odd number of times, the graph will pass through the x-axis at those points. So if a polynomial has answers that appear either once or an odd number of times, the graph will pass through the x-axis at those points. The alternative is if you have a double root or a multiplicity of 4 or a multiplicity of 6. Because remember what that list of numbers represents. Your answers are showing me, hey, these are all of the x-intercepts. This is where the graph is touching the x-axis. If the graph doesn't pass through the x-axis, but it still touches it, what's the only other option? I'll tell you, it can bounce. Oh, yes, your graphs can bounce off of the x-axis. Oh my gosh. So let's write that, and then I'll show you exactly what I'm talking about. If you have a double root, or any even multiplicity, the graph will bounce. I'll show you. Well, I should say bounce at that point. Let's pretend that we were doing some sort of function and we were able to factor it really far. Let's say I was able to factor my polynomial and I got this far. So now, wouldn't I be able to figure out what all the solutions are? What solution comes from this factor? 2. I get 2 again. So I'm going to have 2 as a double root. I'm also going to have -3, and I'm also going to have -1. Because this thing has 4 total answers, what must the degree of the whole thing have been? To the 4th, right? Let me just throw some numbers on here. So what I'm going to do is I'm going to put a dot at all of my answers. So I know this thing is going to hit the x-axis at these numbers. It's going to hit at -1. It's going to hit at -3. And then it's going to hit at 2. So far, is everybody with me?
Yeah.
Okay, so I want you to watch this because this is so cool. This thing must have been degree 4, right? Because I have 4 solutions. So show me with your hands if I have x to the 4th, what are they doing? Reach for the sky, exactly. So that means this end is just gonna go up, off, and this end is just gonna go up, up, up and off. Now, because I only got the answer of -3 one time, that means that this graph is literally gonna pass through the x-axis at -3. I also only got the answer of -1 one time. So this thing will turn around at some point and it'll pass through -1. It's going to pass through here. It's going to pass through here. But now when it comes over here, because 2 is a double root, it's going to literally bounce off and come right back up. It doesn't actually pass through. It just reaches down, touches it, and goes back. Isn't that wild? That's so cool. So the roots being double or single tell me a lot about what the graph looks like. It's either, so if it's a double root, it's going to bounce. Anything else is just going to pass right through. If I happen to have something that had a multiplicity of 4 or 6 or 8 or any even multiplicity, we're bouncing. But if it's odd, we're passing right through like it's nothing. Oh my gosh. All right. So let's try some together. Let's see what we can do. Oh, I've got a whole bunch of these. So what is the AP test you guys have Friday? History? Oh my gosh. Are you ready?
No.
I actually remember taking my AP history test.
Was it easy?
No, oh gosh, no. But what was so funny, I have this very vivid memory of there was a TV show that was an oldie. It was like before my time too, but for whatever reason, I used to watch it. It was called All in the Family, and it's oh, I didn't really watch it. I don't know. It was always, I feel like it was on after a show that I used to watch. So anyway, for some reason, I asked my history teacher about the show, if he watched it or something. I don't know. So we had a quick little conversation about this show, All in the Family. And then it was like, I don't know, a few days later, we had our test. One of the questions was about All in the Family. It was so random and weird. And we're like, what? I can't believe that it was on there, but it was. I don't know. Anyway, that's all I remember about that test. I remember, oh, I do remember that I didn't do well on it, but I also couldn't stand history, to be honest with you. I wasn't surprised. I wish I had done better. Okay. There you are. Sure. Two more?
Mhm.
Oh, I don't know how I discounted so badly. There you go.
Who wants this? I don't want it.
What is it?
I don't know. It's in the jazz.
Okay, let's take a look at just the first one, see if we can work our way through these. All right, so it says, state the maximum number of turns this graph could make. So if you remember, it's just one less than the degree. So in this case, max number of turns would just be 1, right? This thing is just it's a parabola, right? So I know it's only going to turn one time. Determine the real zeros. So we have to find the zeros of this. Luckily, always try and factor. I can factor an x out of this thing, can't I? So let's take out an x, and then you're left with 2x plus 3. So you know what your two zeros are. What are they? 0 and -3/2. Right? Because each factor gets set equal to 0. So I get a 0 from that one, and I get a -3/2 from that one. Nobody was a double root, nothing like that. So list the x-intercepts where the graph crosses the x-axis. Oh yeah. So now you just want to tell me, is it going to pass through or is it going to bounce at each of these? So for this one, they're both just going to pass through. So maybe I'll just write pass at 0 and -3/2. If either of them were going to bounce, I would have written bounce at wherever it was going to bounce.
Wait,
Are you sure? Okay. This one doesn't have any bounces, right? Because I didn't have any answers occurring twice. And describe the end behavior. You can just, we're going to draw it in the graph, but the ends of this thing, since it's squared and my lead coefficient is positive, what are those ends going to do? Reach for the sky. There they are. And then 5, I just want to sketch it. So when we're sketching, listen, I do not need you to be perfect here. Here's what I would be looking for. You would have to have these two numbers. So I'd put a dot at 0 and I'd put a dot at -3/2. So that's -1.5. So I'd be looking for those two dots. I'd be looking at the end behavior. Let me zoom in a little bit. So I know the ends are just going to go up and off like that. As far as the middle is concerned, I don't really care that much. I know it's passing through at both of these, so I know it's going to do something like this. We don't need to be super specific. But these are the things I'm looking for. Do you have a dot at -1.5 and a dot at 0? Are these two ends going up? And then anywhere where it's supposed to bounce, did it bounce? Anywhere that it passes through, does it pass through? So this is a very rough sketch. Let's try number 2 together. All right, so first of all, I need to, what do they want me to say first? How many times this thing could turn around? 3. So max turns would be 3 in this case. Does everybody know where that number came from? It's 1 less than the degree. All right. 2, I have to find the zeros. So I can factor out x squared, can I? So let's start with that. How many total answers are there going to be? 4 total answers. You just found 2 of them right there. What is this? Yeah, you're going to have 0 as a double root. So maybe I'll list my answers over here. So I know I have 0 as a double root. I'm going to have 2 more answers that come from this thing, but I have to do that. So it's just a quadratic. We can try and factor it. The factors of 18, the adds we, yeah, I can. Let's do slide and divide or whatever you do. I can do a -6 and a -3. I did the slide, now I gotta do the divide. So there's my other 2 answers, a +3 and a +3/2. Are you with me? Now, I want to say, where am I going to pass and where am I going to bounce? So what's going to happen at 0? We're going to bounce. So we're going to bounce at 0 and we're going to pass through at the others because they only appear 1 time. 3 and 3/2. Oops, sorry.
For starting to divide, don't you have to make it like the 200 with the absolute?
So you can, but so to get 2x minus 3, but then when you solve it, you get the 3/2 anyway. So. Okay, show me with your hands what the end behavior would be. Reach for the sky again. Why? Because this is an even degree and the lead coefficient is positive, so both going up. So now we're going to start making our graph. So I'm going to put dots at my answers. I have a dot at 0. I have a dot at 3. And I have a dot at 3/2, so that's 1.5. Well, you already know what the ends are going to do. You already told me. The ends are just going to go off up to infinity. But now watch, because 0 is a double root, it's not going to actually pass through the x-axis right there. Let me zoom way in so we can get this real clear. Whoa. There it is. Okay. We are not passing through the x-axis at 0. We're going to bounce. So this one's going to bounce. It's going to come down and it's literally going to bounce off at 0. It's going to turn. And now I know it's going to pass through at 1.5 and it'll pass through at 3. And that, again, is a very rough sketch. Rough, because I don't know how high or low this bump actually goes. Same thing here. I don't know how high or low that actually goes. I just know this is going to be somewhere up here. This is going to be somewhere down there. I'm not really checking for that. I don't really care about that. I care about these 3 dots, the end behavior, and if we're bouncing where we're supposed to bounce and passing through where we're supposed to pass through. How do we feel so far? Does this seem okay-ish? All right, so let me have you try one. Yes, actually, I think 3 would be a great one. Oh, actually, can I change it to 4? Let's just, I want to make sure we do one that has an odd exponent before. If I try 4 right now, please. I don't know.
We should do like 3, 4, and 5.
Well, 3 is an interesting one.
Oh, is it?
It has.
Are there 2 doubles?
Yeah.
Oh. Okay, so I have some of it up here on the board. I'm assuming you guys have the same thing. Max turns, it's got to be 2, 1 less than the degree. For the zeros, were you able to find them as 0 and then you get -3 twice? Okay, now we're getting lucky here that these things can be factored. You might reach one that can't be factored, and then you're gonna have to do like what we did on last night's homework. It's so nice when they can be factored. I have a feeling most of these can be factored, but it's possible to do it without. Any hoosers. So now I have this. So now I can tell who passes and who's gonna bounce. At 0, am I passing or bouncing? I'm gonna pass right through because it happens only an odd number of times. And at -3, we're gonna bounce because it happens twice. Okay, so now I'm ready to, what was 4? End behavior? Yeah. What's this end behavior look like? Show me with your hands. Yes. Oh, wait. No, you're right. Okay, I'm backwards from you. So this side, that's gonna go down and this side's gonna go up like that. Because my lead coefficient is positive. So there's all the pieces. I'm ready to make my rough sketch. So I'm gonna put a dot at 0 and a dot at -3. I know what my end behavior is. That one goes that way, that one goes that way. And then let's see what's happening. I'm gonna bounce at -3. So when I come up here and I hit -3, I'm gonna bounce off of it. I don't pass through, I'm just gonna bounce, but then I will pass through at 0. So it'll look something like that. Again, I don't know how this might only go down a little tiny bit, it might go way down. I don't really care about this piece. I just care that it's somewhere down there. Okay. Let's take a look at what we should do for homework.
3 and 5.
We already did 3 and 5, so let's do 3 and 5.
You know,
You were. What's that? Let's do the whole back page.
I think we should do
3 and 5.
3
I'm
and
thinking let's make our lives easy and we'll do 6 through 8 because that's all on one page. So you can just submit one picture.
What? But 3 and 5, 3, 4.
More practice then. 6, 7, 8 people. 6, 7, 8.
Now I can't keep looking back at the original.
You could unstaple them.
Yeah, it's
And
okay.
you
Just
could
take a
have-
picture.
You can even, oh, yeah, you can take a picture. Look at how you can fold like this. So you can see.
This one is actually.
They're not bad.
Dude, we got triple.
7.
Or yeah.
Yeah, yeah.
Yeah, so take out x cubed and now you get 0 as an answer 3 times. No, you can, that just means that because it's gonna occur as an odd number, it's gonna pass through there. It won't bounce at 0, it'll pass through at 0.
Yeah, what if, yeah, so it'll pass through.
Yeah,
Can
so,
you say that in your answer though, 0, 0, 0?
yeah, or 0 with a multiplicity of 3 is how you would see it. So if that were a multiple choice thing, that's what it would say. 0 with multiplicity of 3. Okay, let me open this on the old Jupyter. Sorry, or not sorry, I don't know, if you want the lights, maybe you don't. I feel like some people want the lights, but they don't want to say that they want them. I don't know.